Uh, my name is Sabir Altabayev, and today I will demonstrate some features of the Dolon Pro. And as you can see, this interface of the Dolon Pro, and I'll first of all I'll briefly go through the user interface of the platform, and then briefly demonstrate some features, and I'll in detail show some specific tools of the 3D modeling instruments. So first of all, about the interface. So this left part of the left panel here appears all layers, and this scene where all the modeling is happening, and right panel. So this is a panel of the object properties. If in the scene anything that in the scene can be selected, and the properties of the object will appear on this panel. So let's start. I'll just start using some tools. So these tools, this panel. So there are several tools to work with polylines and polygons. Okay, let's start to create some polylines. So as you can notice, when I created a polyline on the left side, so this layer was created, this polyline layer, and this properties of this layer. And when I select the object on the right side, will appear the properties of the selected object. So the layers, this layer is specific for the polyline layers, and if we create another type of objects, or if we open some models, so let's say point cloud, this point cloud of topo. So this is a point cloud of DTM, digital terrain model. So when I open this type of object, here I created specific layer for point cloud. The same thing will be for some other, for mesh, let's say. So I'll open some mesh here. Okay. Okay, let's open some 3DB file from the Microminds format. So this is some wireframes, and was created a specific layer here. So these tools are these toolbars are functional toolbars, and these toolbars are some additional toolbars to manage scene. Let's say this one will show all the tools within the scene. So there are a lot of tools here, so that's why we don't have much time, and today I'll show how to model underground workings from the to create underground working mesh from profile and from string path. Okay, let's clear the scene. We'll clean up the scene and let's load some image. We'll assume this example, this sample just for demonstrating purpose. Actually it doesn't have any it's not a real project, and I'll just demonstrate it using some features of our tool. First of all, let's load an image. This image of some underground project plan, and this image has some coordinates. First of all, we need to align this image with those coordinates. So in order to do this, we need to bind this image with the real coordinates. So whenever image is selected on the right side, so you can see the properties of the image and this bind coordinates by clicking this one. So we can set the real coordinates. So this binding points. Okay, first of all, so this one is should be a coordinate of x-axis. The second one, y-axis, and the elevation will be 165. So this is the first bounding point. In order to bind correctly, we need to at least 4 binding points. So this is second point. We'll put the real coordinates, world coordinates. So the third one will be, third point will be here. (9240) and 9340, and the elevation will be the same. And the first and the fourth point will be this point, and the coordinates of this point is so we put the 4 coordinates of 4 points. Now we'll transform this image to the world coordinates. So we'll transform it. You can check just by checking this coordinates. Yeah, this somewhere there, and this here also somewhere there. So this are also coordinates there, and this one also there. So the image was transformed to the real world coordinate. Now, using this image, we'll start some drawing some center line path in order to create a underground workings. So this image will be used as a layer, and in order to use this layer, first we will create the reference plane. So why we need reference plane? Reference plane is needed in order when we want to create some polylines or create points or anything on some elevation or on some plane, in arbitrary plane, we can create the reference plane. Whenever reference plane is set, any further change will be automatically projected onto that reference plane. So reference plane can be set using by this button. So we'll switch on the snap mode. Now then we'll put the point just a little bit above the image. So let's see, the first point will be here, and the second point will be here, and the third point will be here. Using this 3 points, we'll set a reference plane. So the reference plane is set. This is a reference plane. Now any further change that I'll make will be automatically projected onto this reference plane. Right? Okay, let's start to create some line here. So it will serve as a string path. So I created here one string path. Let's create another one. The purpose of this example is just to demonstrate the features of the 3D modeling tools. Okay, we created 2 string lines. Now let's create a profile. In order to create a profile, we can use these tools. So we'll create a circle with the radius of 2 meters. This properties of the circle, show points. Now we'll create, okay, just since the radius is 2 meters, we will create from this point 8 meters width, and switch on the dynamic input mode, and we can go 8 meters down, then 2 meters back left, go further, and we'll just close it. So we've created 2 objects. Now let's unite these objects. So in order to unite two strings to polygons, can be used these tools. So this Boolean tools for strings. So Boolean union. So we united it. Now we need a little bit clean up. So show points, show point labels. Okay, show point. No need to show points. Here we can see that some points were overlapped. Here there are duplicating points, so need to remove duplicating points, and yeah, just that one. This is a closing point. Now we've created a profile. Now we need to put pivot point. So the pivot point, the purpose of pivot point for profile is that pivot point will be attached to the string path, and along this string path will be created the profiles. So let's put the pivot point to this point. Just for this purpose, let's create one segment by snapping perpendicularly. So this intersection point will be served as a pivot point. So currently pivot point is here, but we need to move this pivot point to this one, to this point. To do this, first we need to select the string, then press the control button, and okay, let's switch snapping to points. Press the shift button, and so you can see this point is snapped. So we've put pivot point here. Okay, show pivot point. Now pivot point is on. We've set the pivot point. Now for profile we need to show the up direction. To set up direction, we'll use this button. First of all, we need to select the profile, then set the up direction. So we will choose this point, and this point will be the pivot point, and this point will be up direction. That means this line from the pivot point to this line, this is the up direction of the our profile. When the profile, when the mesh is created, it will be oriented along this pivot point and this the up direction. Now once we created profile and we've created a string path, let's build a solid from this profile and the string path. To do this, first the order is important. First we will choose profile, then we'll choose the string, and by using this button, this tool, so it will create the mesh. So it's already created. When it's created, it's hidden, so we need to make it visible. So this one is our underground mesh. Now we'll do the same thing with this string path. So before to create the, before building the mesh, just a little bit, we need to a little bit smooth this line. So for this, we can use this tool. So smoothing angle in degrees, that means between two segments the minimum angle needs to be this 90, but in our case we need to put 160 degrees. So here appeared some points, so we little bit smoothed our string path. Further, we'll choose this profile. The second one is a path. So remember, the order is important. First needs to be selected profile, then needs to be selected a string path. Once they are selected, just pressing this button will create a new underground mesh. We created now two meshes. So now we need to merge these two meshes. So in order to merge this, unite these meshes, we will use mesh Boolean operations. Before using mesh Boolean operations, all these meshes need to be cleaned up a little bit. This button will clean up the mesh. That means if there are some incorrect connections or duplicated points, those type of errors will be cleaned up and the mesh will be validated. So we cleaned up two meshes, and we need to close those two meshes. Okay, now this button will close meshes. So you can see this is closed, and here it appeared the volume. If you notice, volume is negative, so that means here when it's created, so normals of the triangles were directed inside, not outside. So just once more we compute the volume, then it will, here you can see it will automatically change the direction of normals. So, or you can change direction of normals just by using these three buttons. Okay, let's see the normals. So here also normals are directed inside. In order to compute volume, this normals needs to be directed outside. So we need to invert normals. Just by clicking this button, it will automatically redirect normals. So recompute the normals. Now they are directed correctly, and we'll close mesh. Once the mesh is closed, the volume is computed automatically. So this is the volume, and here this also needs to be once more closed. And volume is here, this one. Now two meshes are created. Now we can unite them by using Boolean operations. So Boolean operations, they have several operation on meshes. So currently, in order to unite, we will use this operation, union operations. So currently just two meshes can be united or intersected or defined inner part or outer part. If you need to unite several meshes, that need to be done sequentially. So first two meshes, then created a new mesh needs to be united to the next mesh. So we'll unite. Okay, now we united, and let's check if these connections are handled correctly. So in order to see the inside part, we can use sections. So sections can be set by using this button, and we'll set the borders of the section. So this by default is 5 and 5. This 5 towards 5 meters and away 5 meters, and the step is 10 meters. Let's leave it as is. So we've created a section, and we can see the inside, and we can see that the mesh was handled correctly. So this is a section, and now once section is set, later just by clicking this arbitrary section, it will be activated, and this is a properties of that section, and these buttons will move through the section to the next section or to the previous one. Okay, so to switch between the sections and layers can be used these two buttons. So this one is layers and this one is sections. So here this layer now doesn't have any mesh, so it can be just removed. We'll remove it. Okay, we've created a underground mesh. So now let's try to create the same mesh, the similar underground meshes at a different elevation. Okay, for this we'll just create a new polyline layer, and we'll activate this layer, create the select these polylines, string path, and since these string paths are the part of this layer, and currently we activated the new layer, this layer, and we'll copy selected polylines to active layer. So we've copied, and let's move these two polylines. Okay, in order to move, we will use this tool, translate tool, and there are three tools that help to move, rotate, and scale any type of object. So I'll just demonstrate this with polylines. First of all, okay, let's move this to the 40 meters. Okay, you move this one the previous polylines. So this now new polylines. Now just to demonstrate the features, we'll use this rotation mode to rotate this selected polyline. We've rotated this polyline, and if there is need to project or to create the mesh with some inclination, so we can use this reference plane here also. Okay, let's demonstrate this feature. First of all, we will set some reference plane. Okay, this will be our reference plane. Just by clicking 2 points, and we can create reference point perpendicular to our view. So I've created this reference plane, and this string now can be projected into that reference plane. So further, if I change anything here, right? So any hour change now will be automatically projected onto the reference plane, because our reference plane now is active. Some part we don't need, let's say don't need this some part. Okay, so we'll split it by deleting segment, and this part we can just delete, so remain that part. Later we'll continue extend it to the another inclination. So now let's create the reference plane to this inclination. So now we'll extend this selected polyline So once we created the polyline that we need, now we can unpin the reference plane. Once reference plane is pinned, any change will be projected to the reference plane. So don't forget to unpin them later. Let's say if I start change this reference this polygon or polyline, so we'll change it. It will automatically, you see, it will automatically project it to the reference plane since a reference plane is already pinned, toggled. So I'll unpin it just by clicking this dynamic reference plane. Dynamic reference plane means that the reference plane will be defined automatically whenever any object or any string is selected. You see, the strings are selected, and the plane of the string is calculated by system automatically. So we've created this string path. Now using the same profile and this new string path, we'll create a new underground mesh. So I selected the profile, then I select the string just by clicking this. We've created this one. So this is a new underground mesh. So we have now this mesh, right? And sometimes it's needed to adjust this type of intersections. In order to adjust these intersections, it can be done by uniting, or let's say we don't need this extra part, so we can just cut out that part. How we can do it? Once we create it, so let's clean up the mesh once more, just to make sure that our mesh is correct. And in order to cut this part, so we can just draw any line, let's say this line. So I'll hide it, this line. And we can cut this mesh by this line. So first need to be selected the mesh, then need to be selected the cutting line. The order is important, and by using this cut mesh by polyline, we'll cut this mesh into two pieces, right? And you need to note that the cutting will depend on the view direction. Let's say if I look at the mesh at this point, at this view, and want to cut this mesh by this polyline, so it will be cut there, in the way that currently I'm looking at this mesh. Okay, just I want to demonstrate this for the just to show the features. Select this mesh, select the polyline, cut mesh by a line, and I looked at in this angle, and it was cut in that angle, right, respectively. So that means just by using some lines from different perspectives, the mesh can be cut differently. So here we've cut the mesh, and in order to adjust, maybe we need to cut not from here, maybe we need to cut a little bit from here. Okay, let me make it in this way. And from this open section, we can create the polyline, extract the polyline, and copy this polygon here, move it, Now from these two contours, we'll create some polyline or some mesh here, and from this mesh, we can cut from this side, or just clothing. This by merging this first. Okay, merge. Then close mesh. Now we will unite it. Okay. Now they've united three meshes. So the purpose of this example was just to demonstrate the features of the 3D modeling tools. I guess I'm going out of a little bit or time, so maybe you have some questions. And don't forget to subscribe into our channel in YouTube. Usually we deploy some tutorials how to use our tools, and some useful links and other materials. And actually there are a lot of tools here, and we have the one tool that I'd like to just mention, that there is a tool that helps to model our bodies automatically. Maybe you are familiar about the implicit modeling. That implicit modeling based on the samples, based on the composites, it will automatically create the our bodies. We have our own tool, our own algorithm that generates the ore bodies, not by using the mathematical method. It's just it's combining method. It's like explicit modeling. It uses pure geological approach with the mathematical methods, and it creates ore bodies in a different way. This different approach than the implicit modeling. I'll just briefly show about those tools. These tools are, if you are familiar with the implicit modeling, you can just use these tools just to test the tools. So in a future webinars, we will definitely demonstrate the features of these 3D modeling tools. So it seems no one have any questions. So then we'll finish the tutorial. Thank you for your attention.